Okay. So, back to this idea of reverse engineering. In order to understand where I'm going with this reverse engineering thing, let's talk about the distributive property for a minute. Now, to distribute means to give out. So, what we're going to do is to multiply this 5 by everything in the package. So, the answer to the first one is 5a plus 10b. I like to look at it as you take the 5, distribute means multiply. So, 5 times a is 5a, and 5 times 2b is 10b. So, to distribute simply means 5a plus 10b. And we've been doing some distributing in the course, but I just want to take a step back here so that we can better understand factoring. Okay? All right, let's try the next one now. Your turn. Okay, so when I do 3 times 7n, I'm going to get 21n, and 3 times negative 4, I'm going to get negative 12. Let's try the next 3. Okay? Actually, do the next 2. Don't do the last one yet. Do the next 2. A little stop and start. Go ahead. All right, so now we get to the third one, and that's going to be negative 2 times x, then a negative 2 times 4y, and a negative 2 times negative 5. For a correct answer of negative 2x minus 8y plus 10. Remember, this 2 outside is negative here. Negative 2 times negative 5 is positive 10. So let's distribute on the next one. Negative 7 times 3x squared, negative 7 times 4x, and negative 7 times negative 1. Remember, you do everything in the parentheses, whether there be two terms like a binomial, or if you have a trinomial, or you can even have 4 terms like in the last one. So negative 7 times 3x squared is negative 21x squared. Negative 7 times 4x is negative 28x. And negative 7 times negative 1 is positive 7. Let's do a little stop and start. You try the last one. Okay, so 9 times 2x cubed is 18x cubed. 9 times 3x squared is 27x squared. 9 times negative 4x is negative 36x, and 9 times 5 is 45. So that's distributing, and that should not be complicated for anybody. There should be a strong comfort level with that. Okay? But what I want you to notice is I want you to take a look at the answers in red for a minute, and then notice something. In every single case with the answers in red, 5a, 10b, 21n minus 12, negative 2, negative 8, 10, negative 21, negative 28, 7. In every single case, there is a greatest common factor. So if I was to reverse engineer, if I was to start with the red question and say, what must you have given me in black to have gotten the red? That is what factoring is, and that is to reverse engineer. So here is a question where you are required to reverse engineer what you already know how to do, like that spacecraft landed and there was the answer. Now the question is, how do I get to that spacecraft and the technology therein? Well, now you know the solution is 5a plus 10b. What must that question have been? Kind of like Jeopardy. Well, it must have been 5 times a plus 2b. And then you always just check yourself back and see if you get the same answer. 5 times a is 5a, 5 times 2b is 10b. This is factoring using the GCF, greatest common factor. You are going to pull it out or factor it out of both terms, see what you're left with, and then here's the key. Just multiply back. And if there's a mistake, it usually becomes pretty self-evident. So now we're going to do numbers 1 through 3, a little stop and start action. And then we'll go over the correct answers to numbers 1 through 3. Go ahead. Okay, so for the first one, it's 5 times n minus 4. Clearly, 5 and 20 share a 5 in common. So I'm going to factor that out, pull it out of the binomial, and I'm left with n minus 4. Now the whole key here is to multiply back, and if there's a mistake, you will see it. 5 times n is 5n, 5 times negative 4 is negative 20. So looking at number 2, you might have been tempted to pull out a greatest common factor of 2 or 4 or 6. Those are all common factors, and it's better than it's not a bad choice, but we wanted the greatest common factor. And in this case, the greatest common factor is 12. So I pull out the 12 and I'm left with g plus 2. 12 times g is 12g. 12 times 2 is 24. When you want to know if you're correct with your answer, there are two things that you look at. First, did I choose the greatest common factor? If you can't factor what's left in the binomial anymore, if there's no more greatest common factor left there than you did. And then you want to check and make sure when you distribute back, you get what you started with. Okay, number 3. I look here, they share a 4 in common. So I pull out the 4 they share in common. I think it's 3x plus 7. Let me multiply back and check. 4 times 3x is 12x. 4 times 7 is 28. There is the correct solution. Okay, so let's have you try numbers 4 through 6 on a stop and start. And 5 and 6 may give you a little bit of trouble at first. You may remember it from prior schooling, and if not, by the time you're done with number 6, I think you'll get it. Okay, so in the first problem, they all share a 5 in common. So I factor out the 5, and let's just check by multiplying back. 5 times a is 5a. 5 times negative 3b is negative 15b, and 5 times 2c is 10c. Looking good. Now you look at number 5, and numbers 1 through 4, we all shared a number in common. Number 5, they don't share a number in common. Now they share a variable in common, namely an a. So let's guess and see if it works. A times a, that's a squared, that looks good. And a times 3 is 3a. So that's the correct solution. Similarly, if I take a look at number 6, what do they share in common? They share an a in common. So I again factor out that a. A times a is a squared. A times negative 7 is negative 7a. Now, so far we have done problems where they shared a number in common. We have done problems where they shared a variable or letter in common. We have not done any where they share both in common. And that is what we're going to do in numbers 7 through 9. So let's have you try number 7 right now, and then we'll have you try 8 and 9. Go ahead, try number 7, a little stop and start. Okay, so I notice, I just do it piece by piece. I say, okay, what do they share in common, the 5 and the 15? I ignore the a's, I'm just looking at the numbers. Oh, they share 5 in common. Now I ignore the numbers, and I just look at the letters and say, oh, they share 1a in common. So I factor out 5a. Now, if I divide out, because factoring is division, just as distributing is multiplying, factoring is division. They're inverse operations. 5a times a is 5a squared. And 5a times 3 is 15a. So yes, that checks back. Okay, let's have you try 8 and 9, a little stop and start. Go ahead. Okay, number 8. They share a 5 and an x in common, right? 5 is the greatest common factor of 10 and 25. X is the greatest common factor between x squared and x. So I factor it out and I get 5x. What am I left with? X minus 5. Let's check it back. Always a quick mental check. 5x times x is 10 is, see? Look at that. Ha ha ha. Made a mistake. You always, 100% of the time, want to make sure you check it back because it's easy to make careless mistakes. This should be 5x times 2x minus 5. Once again, 5x times 2x minus 5. And then for number 9, now I get it right for you. This time they don't share a variable in common because there's no letter with the 21. So it's just 3v squared minus 3v and then minus 7. So 3 parentheses, v squared minus 3v minus 7, and when you distribute back, you get back your correct solution. Okay, let's try numbers 10 through 12 and look for what factoring with the greatest common factor gives us. Little stop and start time, do all 3. Okay, so for number 10, they share a pi in common. That's kind of strange, but doesn't matter. That's what they have in common, and they share 1 r. So when I factor it out, I factor out the pi they share in common and one of the r's. That leaves me with, I think, r plus h. Let's distribute back and make sure. Pi r times r is pi r squared, and pi r times h is pi r h. So that is correct. Number 11. This time, I look at the numbers and I say, hey, they share a 4 in common. But this time they don't only share one n, they share n squared. You're always going to choose the smallest number of n's because that's the amount that they all at least have. See, they don't all have n to the 5th, only the first term does. So the least number is the one you want to choose, the n squared. Now, if I factor out or divide out a 4n squared from 8n to the 5th, 4 divided by 8 is 2. N to the 5th, I took away, or I pulled out 2 of those n's, because I took out n squared, so that leaves n to the 3rd, right? N to the 5th is n, n squared is n, so when I divide out 2 of those 5 n's, there are 3 left. 4 n squared times 5n, 4 times 5 is 20, n squared times n is n to the 3rd, and 4n squared times negative 8 is negative 32 n squared. Number 12, look for what they have as a greatest common factor there. Well, I can see they share 3, and I can see they share 1x. That's what I think the answer is. Let's distribute back and check. 3 times 3 is 9. X times x squared is x to the 3rd. Looking good. 3 times 7 is negative 21. X times x is x squared. Looking good. 3x times 5 is 15x. Looking good. So number 8 was the most important question on this page because it showed you the necessity of quick mental check, multiplying back. That's what you always want to do with these questions. Okay, on to the next video.